ions is sodium acetate going to break into? You're going to have sodium ions and acetate ions. So these are the two ions you're going to produce. So then you're going to add water.
Okay.
Just like we did yesterday. What will be the products of the first reaction?
NaOH and H plus.
Okay. NaOH and H plus. Is this allowed?
It's a strong base.
It's
so
a-
it completely dissociates.
So it completely dissociates. So it doesn't happen. Cannot happen. You cannot make a strong base. If we had, Edmund just said, you would dissociate into sodium ions and hydroxide ions again. So what would we produce if we add our H plus and our OH minus? What does that? It makes water. See, you didn't make anything. You've got exactly what you have on the left-hand side. So if you make a strong base, it doesn't happen. Not allowed.
OH ion, and because it's a weak acid, it doesn't completely dissociate, so the reaction goes through.
Okay, so this is going to make hydroxide ions and acetic acid. The water splits into an H plus and an OH minus. You keep the OH minus because you have a negative ion on this side, so you need a negative ion on this side. And that H plus goes with this conjugate base, and you make its acid. So if you have a conjugate base over here, you've got your conjugate acid on this side. If this is a weak conjugate base, it comes from a weak conjugate acid, a weak acid. So this one will go. So in the end, because we produce hydroxides, this solution of sodium acetate will be basic because you make OH minus. So one person was correct.
Well, you weren't here to vote.
You weren't here to vote. You want to vote for the next one? Acid, base, or nothing?
Which one's the next one? Oh, that one.
Ammonium acetate.
Nothing.
Okay, we've got two nothings.
Yeah. Totally agree with that.
Okay, so your two ions. You've got an ammonium ion,
Oh.
and you've got, again, an acetate ion. We already know what the acetate ion is going to do. The question is, what is the ammonium ion going to do?
With water, it makes NH3 and the OH plus. I mean H plus.
Yeah. So this is the weak conjugate acid of this weak base.
Oh, it is a weak base.
Yep. Anytime you have a nitrogen in a compound, it can act as a weak base.
Yep.
Because of the lone pair of electrons.
So it doesn't do the opposite?
So-
like the chart said?
So this, yeah, you do have to do that. So this is gonna be, if this is a base, that's its conjugate acid,
Yeah.
right? That gives up its H plus to water to make H3O plus and its conjugate base partner. So now, because we've got a weak acid base conjugate pair, we've got a weak acid base conjugate pair, you've got to see which one of these two is the strongest. So you've got to compare the Ka for the ammonium ion to the Kb for the acetate ion. So look it up in your textbook. So, yeah, because your Ka and your Kb are the exact same strength, it's neutral. If your Ka was larger, it means the acid is stronger than the base, so it would be acidic. If your base, your Kb, was stronger than your Ka, it would be basic. If you get the exact same value, it's pH of 7. Ammonium acetate is often used as a buffer. A buffer contains a conjugate acid-base pair that has a certain pH. In this case, it's a pH of 7. So that if you add a little bit of base, Le Chatelier's principle uses it up and it flips to the other side. It shifts equilibrium. So your body has a buffer in it. Your blood has the bicarbonate ion in it, and that buffers your CO2 in your blood. Anybody here know anybody who sometimes can't breathe and they have to breathe into a bag? Like a brown paper bag? To increase their amount of CO2 getting into their system and into their blood to raise the pH. It's pretty cool. If I only add 20 mils of sodium hydroxide, I have used up all of my acetic acid. It's not there anymore, correct? Okay. I don't add an excess amount of sodium hydroxide, so I've used up all my moles of my base. Water, we never concern ourselves with water. Okay, so we've used up all of our acid, all of our base. We're not concerned with the water, but we do have some sodium acetate. How many moles of sodium acetate do we have? What's the mole ratio? What is the mole ratio of acetic acid to sodium acetate? 1 to 1. So we have it doesn't matter really which one you use. I'm using acetic acid because it's got a common ion. So we have 0.006 moles of sodium acetate. So over the total volume, so the number of moles divided by the total volume, because it's both of them mixed together, and you get
It's 0.155.
0.15 mole per liter sodium acetate. Beautiful. And we haven't really begun the question yet.
Water, it makes NaOH, which is a strong base, so therefore it doesn't react. But the acetate ion, when it bonds with water, it makes acetic acid, which is a weak acid, so it goes.
Thank you.
Where does it go?
The reaction goes back.
There's those two.
So this is why I had you do those questions last night. So if you have sodium acetate in water, the acetate reacts further in the water to make a slightly basic solution. So now we're going to figure out what our pH is of this reaction. So now we can figure out the pH at equivalence point, which is what the question asked for. So we know we have 0.15 mole per liter of this. What do you think we have to do? Right? Yeah. Need a nice table. So, set it up. Don't care about the water. Did he just swear? Did he just swear? Did he just say, get a effing ice table? Out of all the students in this classroom that I would think that would say that, not you. Oh. What do you mean again? What?
In English.
Okay. So our ice table. 0.15 minus x, x and x. We need to set up our k expression. So we have a KB. We have a KB, not a Ka, because we make hydroxide ions. So this is going to have an equivalence point pH of greater than 7. Strong acids, strong bases have an equivalence point at 7. So our KB is our weak acid concentration times our hydroxide ion concentration over our conjugate base concentration so we need our KB value. You've already determined it, and it was
We know KD
5. Was it 5.6? 5.6 times 10 to the negative 10. 5.6 times 10 to the negative 10 is equal to x times x over 0.15 minus x. If you want to do the quadratic equation, go ahead. The rest of us are going to make the assumption that 0.15 minus x is 0.15, because 0.15 divided by 5.6 times 10 to the negative 10 is way greater than 1,000. Yeah. So 5.6 times 10 to the negative 10 times 0.15 is equal to x squared. Take the square root of both sides.
What? That's a figure.
Nine
9.17. Thank you. 9.17 times 10 to the negative 6. This is our x, which if you go back to your ice table is also equal to the hydroxide ion concentration. So you've got two different ways to figure out your pH. You can calculate minus 14 minus pOH. So 14 minus the negative log of 9.17 times 10 to the negative 6, or figure out what your H plus ion concentration is, and take the negative log, that's a comma, take the negative log of that value. So it's definitely more detailed than a strong acid, strong base question. A little bit painful, not gonna lie. And that's it in a nutshell. A weak acid with a strong base, your equivalence point is gonna be greater than 7. And then if you've got a strong acid and a weak base, your equivalence point is going to be less than pH of 7. Or you just stretch it.